in the diagram, A, B, C, D, E, O, that is A, B, C, D, E, O, is 2/3 of a circle center O. So it's 2/3 of the whole circle centered at the point O here. The radius AO is 7 cm. That is, the radius from A to O is 7 centimeters. And AB is equals to BC is equals to CD is equals to DE, which means all these points here are radii and they are all equal. Calculate, correct to the nearest whole number the area of the shaded portion. Just listen to this. These portions are all equal. They are equal. So the angles subtended at the centers are also equal. So what it means is that if this place is theta, this is also theta, this one is also theta, then here is also theta. So every part here is equal, which means each subtends an angle of theta at the center of a circle. Also, what we're going to do is to take one, just bring one. Okay, look at it. This is it. We are taking just one, and this is theta. Let's call this one OAB. Let's call it OAB. First, what is theta? We are aware that this one here is 2/3 of the angle, so which means theta plus theta plus theta plus theta, 4 theta. What it means is that 4 theta, because when you add it, theta plus theta plus theta plus theta, 4 theta is equals to 2/3. 2/3, that is 2/3 times 360, because the total angle is 360 degrees. Remember, we are looking for theta. So it means we have 4 theta to be equals to 3 into this. Just multiply and divide. There's no need to wasting time, okay? So 2 times 360 is 720. Then divide by 3. That is 240. That is 240 degrees. Then we are going to divide both sides by 4. Divide by 4. Just to get the value of theta, which is the angle in one of the sectors. Okay, if we divide by 4, 24 divided by 4 is 6. So that is 0 here. That gives us 60 degrees. So which means the angle here is actually 60 degrees. Don't forget, this point here is 7 cm. Here is 7 cm. We are to find the shaded part here. This shaded part is a segment. Find the area of the whole sector. So the area we are looking for is equals to area of sector, okay, area of sector AOB minus the area of triangle AOB. This is what we are going to use. Now, what is the area of sector AOB? Look at the area of a sector is theta over 360 degrees times pi r squared minus the area of triangle AOB, which is half r squared. Okay, then sine theta. Now just call it sine theta. So theta is 60. That gives us 60 over 360. Okay, in degrees. Remember, it's 60 degrees. Okay, then times pi is 22 over 7 times r. What's r? 7. So we have to square it. That's 7 times 7. Okay, then minus half times 7 square again, then times sine. Okay, sine theta. Theta is 60. So we're going to have 60 degrees. Just use calculator, evaluate it. That's 154 divided by what is left here, which is 6. Then minus. So what is sine 60 times 49? Okay, this is 49. Then times 1, which is 42.434. Then divided by this 2. Now what we are going to do next is to divide. Okay, divide 154 by 6. So let's go ahead. 154 divided by 6. That gives us 25.67. So it means our area will be 25.67. Then minus, let's divide the other one, 42.434 divided by 2. That is 21.22. So this gives 21.22. Then we are going to take the difference. So what's the difference? We have 25.67 minus 21.22. That gives us 4.45 centimeter square. This is the area of one of the shaded portion, just one. Remember, they are the same. So we are now going to multiply by 4 because we have 1, 2, 3, 4. So the area in total, as A subscript T, that's the total area of 1, 2, 3, 4, is equals to 4 times 4.45, okay, centimeter square. So let's multiply by 4 times 4. That is 17.8. Okay, 17.8. That gives us 18 centimeters square. So this is the area of the shaded parts, okay, all together in this circle.